Number 13, define the following, starting with bond length. Bond length is the distance at which two covalently bonded atoms minimize their potential energy. Realize there's going to be an electrostatic attraction between the valence electrons of one atom and the nucleus of another atom. And because that attraction is pulling them together, it is actually a lower energy construct if they become closer, right? If the distance between them decreases. But as they approach one another and they become extraordinarily close, okay, you start picking up the positive charge from one nucleus interacting with the positive charge of the other nucleus. And we should know that positives and positives repel one another. And so if we get too close to one another, we're going to have the nucleus of one atom repel the nucleus of another atom. And so we're actually going to need to add energy to the system to get them to get even closer together. Right? Well, now that we're adding energy, that's a high energy construction. Okay, that's a high energy configuration. And so that's not going to be favored by nature. In fact, there's this balance point at which you can get as much satisfaction of the electrostatic attraction, right? The electrons from one atom and the nucleus of the other. There's a balance between that and the repulsion between the two positively charged nuclei. There's a balance point where if you get any closer, you start feeling more of the nucleus repulsion. If you go any further apart, you start feeling that electron nucleus attraction. So the balance point is that point at which that potential energy is minimized. So whatever distance at which there's that balance point, that minimum energy, that is the bond length. Closely related, but not the same thing, bond energy. It's the energy required to break a chemical bond and form neutral atoms in the gas phase. Now, it has to be in the gas phase because that way we can attempt to minimize intermolecular forces, which we haven't gone over yet. But that's just part of the definition. You don't necessarily need to understand why that's important. Just remember that it is important. It has to be in the gas phase. But if this particular bond is very strong, it's going to require a lot of energy to break it. And so bond energy is also used as a measure of strength of particular bonds.